Okay, Module 24.2, Understanding Inverse Functions. The one good thing about this particular lesson is whether you're finding inverse function or whether you're relating it graphically, all you're doing to get inverse is you're switching the y and the x. So in other words, if you graph the line y equals x, it should go right in the middle of your graph and the graph of your inverse, because all you're doing is you're flip-flopping these two. You're just exchanging them out. So we're going to look at some different examples here of how to do that. Now they give you an example here of a graph of a function here, and then the inverse here, and then you notice the line y equals x goes right down the middle of it. That's not very good, but you get the point of being able to see it. Here's another example right here of, here's the line y equals x. Here's the graph of the original function, and then here is the graph of the inverse function, and you see it goes right in between them, right in the middle. Why? Because you're switching your x's and y's is all in essence you're doing. So when you talk about inverse, you need to understand it. And we talk about here the additive inverse of 3 is -3. Okay, the multiplicative inverse of 5 is 1/5, or dividing by 5. Okay, just opposite relationships. So it says graph the relation and connect the points. So you're graphing these points, you're connecting them. Then it says all you want to do is the inverse. So all you're doing to get the inverse is you're flip-flopping these. So your y's here all now become your x's here. Your x's here all now become your y's here. You graph those new points. Then when you graph the line y equals x here, it goes right down the middle of the graph. So that's a graphical representation of inverse. This is a more mathematical or algebraic relationship. Now, what happens in terms of the domain and range? Whatever was the domain on the original now becomes the range on the inverse. And the same thing, the range on the inverse, or the original, sorry, becomes the domain on the inverse. Why? Because your x's become your y's, and your y's become your x's. They just flip-flop is all that happens. So we go back and look right here. Our domain went from 0 to 8, and there's our domain relationship. Our range went from 2 to 7 right here. So now we're right back to this problem again, doing it as we did. The domain is what? X, such that x is between 1 and 7. Okay, now if you need, we're going to do our domain. So our domain is our y, or sorry, our range. I spoke there. So our range is y such that y is between 2 and 9. Okay, now for our inverse, one of the things I'm going to go ahead and show you, the book doesn't really do this, but a notation for inverse is this right here, this -1 right here. And I do that to help me realize over here when I'm doing my set of points or values that I'm doing this for my inverse function. So all I'm going to do now is I'm going to come over here and I'm going to flip-flop these. So now this becomes 2, 1, becomes 4, 2, 6, 3, 8, 5, and 9, 7. These are my x's, these are my y's. Now I'll just plot those points. So if I plot those points, I have the point 4, 2, which is right here. I have the point 2, 1, which is here, and then 6, 3, and then 8, 5, and then 9, 7. So those are all the inverse points. There again is the line y equals x, which goes right down the middle of them. We state our domain here for the inverse. So our domain now is what our range was over here. So our domain goes from x such that 2 is less than or equal to x is less than or equal to 9. Our range now becomes what our domain was in the original, which is y such that y is between 1 and 7. So So it's just a flip-flop of X's and Y's is all it is. Okay, so this says use inverse operations to find the inverse and check your solution. So I'm probably going to do this slightly different than the book does, but I always write this as y equals 5x minus 7. What I'm going to do is I'm going to flip-flop these, and a colored pencil might not be bad here so you realize when you're doing your inverse, but I'm just going to switch these up. So this now becomes x equals 5y minus 7. Now I want to solve for y. So how do I solve for y? I add 7 to both sides, so it's basically just solving an equation. So now I get x plus 7 equals 5 over y, or 5 times y. Then I divide everything by 5. Let's cancel. So now I've got x plus 7 all divided by 5 equals y. But y here is my inverse. So that's where I use this notation. And you'll see it in Algebra 2 for inverse. So there's my inverse problem. Now, how do you check your solution? Well, there's a couple ways. One is you can do some points on your table. So you put this function in for y1. You put this one in for y2. Then go look at your table of values, and then what should happen is they should be kind of flip-flop. So that's one way to do it, and I'll show you more on the calculator how to do that. Another way is by doing what's called a composition, and that's what you'll learn in Algebra 2. But the final way is just to graph them. So if you graph the original one here, and you graph this one now, what should happen is when you draw the line y equals x, so you can put y equals x in for y3, make it a fat line. Remember, it should go right down the middle of them, and that's another way to check it. Okay, so now we want to come to this problem, write the inverse of each function, then graph the function together with its inverse. So now this is basically what I was just talking to you about determining the inverse. So in this case, they've already graphed it for us. There's the line y equals x going right down the middle, splits it. But let's work again on how do you find the inverse. So again, what I'm going to do is basically this is y, so y equals 2x minus 4. Then I'm going to flip-flop my x and my y. So now it becomes x equals y, 2y, sorry. Do that. 2y minus 4. Now I want to get y by itself. I don't know why I'm struggling to write here. So now I add 4 to both sides. So I get x plus 4 equals 2 times y. Divide everything by 2. And then again, I always use this notation, and it's good to go ahead and learn it because it'll help you in Algebra 2, equals f of inverse of x, and there's your inverse function. And then if you graph this, and you graph this, then that's where that graph comes from. So, application of inverse function. To make tea, use 1/6 teaspoon of tea per ounce of water plus a teaspoon for the pot. Use the inverse to find the number of ounces of water needed if 7 teaspoons of tea are used. Okay, so what do we have? It's basically a ratio relationship. It says to make tea, use 1/6 teaspoon of tea per ounce of water. Okay, so we use 1/6 teaspoon of tea per 1 ounce of water, plus a teaspoon, 1 teaspoon of tea for the pot. Okay, so use the inverse to find the number of ounces of water needed if 7 teaspoons of tea are used. Okay, so what we're thinking about here is basically what we don't know is, in this case, how much water was being used. So from our relationship up here, basically what we get is this kind of equation. We've got T equals 1/6 W plus 1. The total number of teaspoons is 1/6 per water per being our slope. Okay, so 1/6 here being our slope per water plus the 1 ounce or the 1 teaspoon we add in the pot itself. So there's our function. Now, to get our inverse, what we're going to do is we're going to switch this. Okay, so we're going to switch T and W. So now this becomes here W equals 1/6 T plus 1. Now I'm going to solve for T. So I'm going to subtract 1. So then I have W minus 1 equals 1/6 times T. To get rid of the 1/6, we multiply by the reciprocal, which is 6. Now I have to use parentheses here because I'm multiplying 6 times this whole quantity. So if I do that, I get 6W minus 6 equals T. Now, what that does now, that's the formula, but remember this is the inverse. So really what I have is 6T minus 6 equals W. So to figure out how many ounces of water are needed, all I do is take, in this case, my 7 teaspoons, put that in right here. So I get 6 times 7 minus 6 equals W. 42 minus 6 is 36. So I have 36 ounces of water whenever I use 7 teaspoons of tea. To be very honest with you, I'm not a big fan of using inverses whenever doing a word problem. Basically what I would have done in this particular case, and again this is just completely up to you how you want to do it, but as I try to clear everything out here, what I would have done in the original problem is I just would have looked at it and said, take the original problem, which was, in this case, I have 7 teaspoons. So the relationship is T equals 1/6 W plus 1. I would have just plugged 7 in right here. And then I would have worked the problem out from there, which is minus 1, 6 is 1/6 W. Then to get rid of the 6, here you multiply both sides by 6, and you still end up with the same answer, which is 36 equals W. So there's not a whole lot of purpose in finding an inverse function for word problems. You can just use the original equation and then just plug in what you know. So I don't see much application to it, but you can do that if you want to. For your homework, this is on page 1173. You guys are going to be doing numbers 1 through 21 odd. 1 through 21 odd.